Hello, everyone. Welcome to this week's lecture and demo. This week, we're going to be covering a couple things. We're going to be covering separation, we're going to be covering staying in bounds, and then also, I just want to quickly cover a little issue that you might have run into with the evade and the flee the evade and the pursue that we coded last week. So we'll get right into that. So first, I'm just gonna show what my project 3 looks like right now after the check-in. So I have my humans, they're evading the zombies. You might only have one zombie and one human in the world. That's fine if you have only that, but the key is that they're getting spawned in with this game manager that I have. I could start it with only one if I wanted to. But I have this game manager. You might call it scene manager. You might call it world manager. Anything. You just should have a manager script of some kind that can spawn in humans and zombies. And the key for me is that I like to be able to tune how many I want to spawn in. So if I want to spawn in 60 humans and 20 zombies, I could handle that in here. And I don't know how powerful your computer is. It might not handle this many. That's fine if it doesn't handle like a ton. But the key is to be able to pick how many of each you want to be able to spawn in, and manage a list of those that can be accessed by the humans and the zombies. So my game manager has a list of humans. It has a list of zombies. And then the way that my zombies are working right now is my zombies are finding the closest human to them and they are pursuing that human. The humans are looking at all the zombies that are within a certain range of them. They have like a sight range, and they are evading all of those zombies. And an interesting thing that you can see here, there's a couple things. You can see this zombie and this human right here that I'm sort of circling. This human seems to be bouncing back and forth between the zombie. And there is, I think, a reason why that's happening that I kind of want to explain and then fix. So I'm just going to open up a paint program just to kind of illustrate what is going on here. So let's say that I have my uh, human here, that I'll have my human be a circle, and I have my zombie that is a square. All right, so this is the zombie, this is the human. And the zombie is going towards the human sort of in this direction, and the human is running away from the zombie in this direction. So the human is evading the zombie. And if we look at where the zombie is here, the we're looking at the future position. So the human is saying in 1 second the zombie is probably going to be about here, so I'm going to flee away from that point. Now there's an issue though. What happens when I'll draw another one down here? What happens when this is our human here and this is our zombie that's gotten closer? What happens if the future position of the zombie is on the other side of the human? So the zombie is closed in on the human, and the human says, "Oh, the future position of the zombie's over here, so I want to flee away from that." In order to flee away, the human is now going to go in this direction, immediately into the clutches of the zombie. So I think there's a pretty simple fix for this. Once you know exactly what the problem is, right? The zombie's getting closer and closer and closer, and when they reach a certain point, there's a distance between the zombie and the human. There's this distance here, where the distance between the zombie and the human is going to be smaller than if this is my future position, then I'll call this distance 1. So my distance in 1 second is going to be bigger than my current distance away. So this is, I think, maybe a simplified way to look at this, right? So in 1 second, the position is going to be ahead of the human. So the human's going to flee this way, back towards the zombie. And that's not what we want, right? If the zombie is getting close to the human, they should be more scared. They should be trying to run further in this direction. But right, that's not what's happening here. So I think there is a simple fix for this. Basically, all we need to do is we need to say, all right, if this distance is ahead of me, if the distance in 1 second, if this magnitude here of that from the zombie to their future position, if that distance is greater than the distance between the zombie and the human, then instead of evading the zombie, we should just flee from them because they're so close that it doesn't matter anymore. So that is what I'm going to code essentially here. And hopefully that makes sense. If it doesn't make sense, I can go into more detail. Just send me a message on Slack if you think I need to go into a bit more detail on this. But hopefully this explains it to the point where you can kind of get what's happening. So let's hop over into my code. I'll go into my vehicle code and I'll go into my evade function. So rather than working with the distance itself, I'm going to work with square distance instead, because I have the square distance between the zombie and the human, and the distance between the zombie and its future position. And if I'm comparing the square distances, it's basically like I'm just comparing the distances because, you know, it's just the squared versions of them. And I'm only going to be checking to see if this is smaller than, if the magnitude of this is smaller than the magnitude of the other one I'm looking at. So it shouldn't matter if it's squared or not. So I actually wrote this little helper function here that I call getSquareDistance. I made it protected so the child classes can access it. And all I'm doing here is I'm just getting the square magnitude of another vehicle's position to mine, just as a little helper function, so I didn't have to write this out every time. I could just call getSquareDistance. So right now, all we're doing in evade is returning a flee on the future position. So we need to do a quick check on that, right? So let's say my vector3, we'll call it my future position, is equal to my target. Actually, I can just copy and paste this. So I'm going to cut this out. I'm just looking for my future position in seconds. And then I am looking for my, let's say, I want to get a vector3 that is the distance between my target vehicle and its future position. So I'm going to call that, you know what, I'm going to do a float. I'm going to call it future distance. And that is going to be the square, the vector3 dot square magnitude of the target vehicle's position minus the future position. So this is going to be the magnitude of this vector here. And then I'm going to have a float for the distance from the vehicle. So I'll call that dist from target. And that is going to be, I have this function down here for getSquareDistance already. I have it already written, so I'm just going to get square distance between the target vehicle and myself. So that's this vehicle that I'm in right now. And then I'm going to say if my future distance is greater than my target distance, I'll reverse it so it's a little bit easier to read. So if my distance from the target is less than the future distance, so if I'm closer to my target than my target is to its position, or if the target is closer to me than the future position for it, then I'm just going to return, I'm just going to flee from my target vehicle. And if it's not, then I'm going to flee from the future position. So I'll add a comment here. If target is closer to me than from its position in 1 second or in X seconds, flee from the target rather than evade. And we can write this same functionality for pursue as well, because we're gonna have the same issue when we're pursuing. So here we're going to say vector3 future position equals target vehicle dot get future position in seconds. Then I'll have a float future distance from the target vehicle dot position minus the future position, and then float distance from target. And that's going to be get square distance target vehicle. Then if my distance from target is less than my future distance, then return seek. I'm just going to seek my target vehicle. Otherwise, I'm going to seek the future position. All right, so now if I go back into Unity and I click play, so as the zombie gets closer to the human, these are the ones I'm tracking here. You can see that the humans, even though they're really close to the zombie, they're still kind of evading that zombie successfully. And they're colliding, but I don't really have my collision set up yet. All right, so the next thing that we're going to deal with is this issue where look at how many zombies are stacked up on top of each other. Same with the humans. There's so many humans that are all just stacked up here on top of one another. That is sort of unnatural behavior that we want to kind of get rid of next. And the other thing, I kind of want them to face in the right direction. So I'll do that as well. So that should be in my set transform here. I want to set the rotation of it as well. So I'm just going to say that my transform.rotation is equal to quaternion dot look rotation. I want it to look in the direction that it is moving in. So I'm going to say for my forward vector, that is going to be my direction vector, and my up vector is going to be the world up. So just vector3 dot up. So now if I go back into my game, you should be able to see which way they're facing, at least a little bit. All right, so that deals with that. So let's actually talk about getting them to separate away from one another. So this week we're going to be talking about separation and staying in bounds. The lecture is quite short, but I'm going to do it all as a demo so that you can kind of see exactly what I'm doing. So for separation, the goal of the vehicle is to give themselves some personal space. So we want to change the vehicle's desired velocity to steer away from their neighbors. So if a vehicle thinks that they're too close to another vehicle, we want to change the direction to steer away from vehicle's neighbors. So first, I'm going to go start from the most simple version of this and get a little bit more complex each time. So first, we'll say that we only have enough brain power to steer away from a single neighbor at a time. So we want to find our closest neighbor when it's too close to us. And then if it's too close, we want to steer away from it. So this can be pretty simple to program. We already have Flee programmed, but some of the cons of this are that it might steer a vehicle right into another vehicle because we're only concerned about one, and it doesn't look very good for a lot of vehicles. So I'm not actually going to code this one. I'm going to jump straight into the second one because this one essentially we first need to figure out who the closest one is, and then once we figure out who's closest, we need to steer away from them. And I think we can do better than that right off the bat. So we'll talk about the second version that's a little bit more complex. So we basically want to steer away from every nearby vehicle that is too close to ourselves. So in the vehicle, we can find all of the nearest neighbors within a certain range of ourselves, and then we can steer away from those at an equal weight. So this is going to look better than the first one because there's going to be a lot of vehicles in our scene, but it is a little bit more complex. But I'll get into that right now. So let's go into our code. And I'm going to do all this in vehicle so that it has access to it in the human and the zombie. I want this to be, first I want to define a amount of personal space, I'll call it, that I want the amount of space around a given vehicle, and I want it to be tunable so in the editor so that I can change it. So I'm going to make it a serialized field. I'm going to make it a private float called personal space. And I'll set it to be 1 by default. And I'm actually going to add another tag here. I'm going to add a tooltip tag because I don't think personal space is super descriptive. So if I was to give this to a game designer that might want to change this, or if I wanted to come back in the future to change what this value is, I don't exactly know what personal space means. So I'm going to say the amount of room around the vehicle where they should separate. And I'm going to actually change this, instead of the amount of room, the radius around the vehicle where they should separate from other vehicles. So I am going to use this to code my separation function. So I am going to call it, I'm going to make it a protected function that returns a vector 3, and I'm going to call it separate. And this is going to take in a list of vehicles. And it's going to be a list of vehicles to, I'll just call it other vehicles. And this list of vehicles is going to be the other vehicles that I want to separate from. And actually, other vehicles is maybe a bit not descriptive. I'm just going to call it vehicles because the human list also contains this current vehicle, and the zombies list that I have also contains this current zombie that I'm in. So in this list, I'm going to make a sort of like the ultimate force that we have. I'm going to call it a vector 3 separation force, and it's going to be equal to vector 3.0 to start off, and then I'm going to return that separation force at the end. And then in here, I'm going to say for each vehicle in my vehicles collection, so for every vehicle in this collection of vehicles, I call this other, just so I can track what it is. So for every other vehicle in that list, I want to separate from it if it's too close. So the first thing we can do is we can check to see if the square distance between myself and this other vehicle is less than that personal space variable that I made times personal space, because we want it to be squared. So I want to make sure we're checking the square distance against this square personal space. And then if we are within that range, then we want to flee from the other vehicle. So that's it. We just want to flee away from them to separate ourselves from them. And we need to make sure that we're actually adding that flee force to our separation force. Now, there's one edge case in here that see if you can figure it out. So this list of vehicles is going to be for the humans, it's going to be a list of all the other humans that I want to separate from. And for the zombies, it's a list of all the other zombies that I want to separate from. But what happens if I get to the current human or the current zombie in this list? We need to add another check to make sure that it's not actually the same vehicle. So there's a couple of ways that we can check to see if this other vehicle is actually the current one that we're in. But what I'm going to do is I'm just going to say that if the other vehicle, actually here, let's say vector So I'm going to have a variable for the square distance that I calculate up here. I'm actually going to use it twice, so put it there. And then I'm going to say if my square distance is less than mathf.epsilon, then I want to continue, which means I'm going to skip over the rest of this and move on to the next one. So essentially what I'm doing here, this will only happen if the other vehicle's position is exactly the same as mine. The reason why I'm not saying equals 0 like this is because of floating point math imprecision. There is a chance that it can be a really, really tiny value because of the way that computers work. So I'm just checking to see if this is less than essentially nothing, and then I'm skipping over it. You could also do things like you could check to see if the other vehicle is equal to the current vehicle, but if it's a child class, then there's some other considerations you might need to keep in mind there. So I find this to just be a pretty easy way of doing it. So now if I go into my code here, oh, I'm never actually calling that function. So I need to actually call that function. So in my human class, in my calculate steering forces, when I do all of my other calculations, I have this calculate zombie evade force down here. This is where it goes through all the zombies and evades all the zombies within a certain sight range that I have here. I also want to say ultimate force plus equals separate, and then I have a reference to my game manager already set up, and I want to use my list of humans. And I might need to change this function instead of being a list of vehicles. I think I need to make it generic. I need to make it a list of T, where T inherits from vehicle. So I just need to make it a generic function. And now it'll work. Yeah, so I just need to say separate and make it generic here. And then zombies as well. I have this function where it finds the closest human and then it pursues that closest human. And then I just need to say that I want to also separate from the game manager dot zombies list. So now if I go into my project, my game window, let's take a look at what this looks like. So now the humans should be, they're getting a little bit clumped up. I might want to make their personal space a bit bigger. But you can see that as they're fleeing away, they're getting a little bit too close for comfort. And let's see what happens when this zombie comes in. Are all gonna flee away, but they're not quite colliding. So that's good. The zombies over here, they're starting to bunch up. They're kind of getting away from each other. But I want to go one step further. So let's go back over to the slides and take a look at what that is. So this is the third version of separation, where essentially we want to pay attention to all of our neighbors and steer away from them proportionally. So we're going to use weights here to weight the force based on how close we are to our other neighbor. And our weight is going to be inversely proportional to the distance away. So here I'll go back here into my my drawing. And let me draw this. So let's say that we have a human here, and a human here. And our personal space is maybe this big around this human here. Not quite the perfect circle, but what can you do? So this human here is super close to this one here. And this one over here is not very close. So we want to steer away from this one a little bit, but we really want to steer away from that one. So to do that, we can take the distance we are away from this other human and we can make it inversely proportional. So if we go back into the code for this, go back into our vehicle, we can multiply this force by 1 over, multiply it by 1 over our distance away. And we can get even a little bit better than 1 over the square distance. We can say that we have a, let's have a float for our personal space radius. And that is going to be personal space times personal space. And then we can say, so instead of doing 1 divided by this square distance, we can actually say personal space radius divided by the square distance. So now as the other vehicle moves closer and closer and closer to our vehicle within this personal space radius, we will make sure that we divide by that and scale it appropriately. Now we want to make sure that we're never dividing by 0 because this could potentially cause an error. So if the square distance, actually right here we're saying that if the square distance is less than our mathf.epsilon, so if it's less than the smallest possible value, then we'll continue. But what I actually am going to do is I'm going to say that if my square distance is less than, I'm going to say 0.001, just to be safe. Then I'm going to say that my square distance is equal to 0.001f, because the other issue that we can have is that we could potentially get so close to the other character that multiplying by it would give us a number that is bigger than the mathf dot max float value. So our max float value is some ridiculously huge number, but as we approach 0, we're more and more likely to get that number or exceed it. So we don't ever want to have like weird floating point errors where our floating point numbers are way too huge. So I just add a couple checks like this. I might actually make it 0.0001 just for good measure. So if our distance ever gets too small, it's still going to be smaller than our personal space. So changing this value isn't going to affect this at all. But yeah, I just want to make sure that our scale for this force is never excessively large. All right, so then if we go back into Unity and hit play, it should hopefully separation should look a little bit better. And I'm gonna go in the scene. There's still definitely some issues, and you know, as our zombies get really close, there's some issues as well. But they are staying separated. And in my human, I might want to change my personal space to be a bit higher, maybe like 1.5. And maybe my zombie, I want to give it a little bit more personal space as well. So let's say that my personal space for the zombie is going to be 2. The zombies want to stay far away from each other. We hit play again and take a look. Yeah, so now they have a little bit more room, and actually if I select all of the humans, you know what, let's do something where in my game manager, let's have 1 zombie and 200 humans. So this will look pretty interesting. So yeah, you can see how all of the humans are going to try and stay away from this 1 zombie. And they're going to try and stay separated from one another. So I'm going to select all the humans in my scene, and I'm going to give them more personal space. And let's give them a huge sight range, like 500, so they can always see the zombie. So as we, you know, get less personal space, like maybe it's 0.05 or something, they're not going to separate from each other very much. But if I set it to like 2, now they're going to try and start separating from each other. Maybe they need a lot of room from one another, like they need 5 from another. So you can see they start to separate, and it might be a little bit easier to see over here. So they're all still trying to run away from this zombie. Zombie seems to have gotten stuck trying to find this this human over here. So let's work on the next issue, which is staying in bounds. So you notice that when I was playing this here, my humans can kind of get to the edge and bounce around. I'm using the bounce function where they're bouncing on the edge there to try and stay in the bounds. But we can actually do better than that. We can use forces to keep them staying in bounds. Let's take a look at what that looks like. So, how does this vehicle know how to stay in bounds? Well, we already know how to check to see if something is outside of the boundaries, right? We can check to see if the position is bigger than the X position is greater than the bounds here. Same with the Y and the Z. In this case, it's the Z position since we're in top down. So the simplest way to do this, which is what I'm going to show, is if an agent is out of bounds, then we can just seek towards the center position until they're back in bounds. And that's it, really. We just want them to seek towards the middle. The second method that we can use, which is a little bit better than this, is if we go out of bounds, we can find the closest point that's still in bounds and seek towards that. And then lastly, the sort of like best method that I would say is we can look at our future position of our vehicle, see if our vehicle will be out of bounds. And then if they are out of bounds, we want to steer them back in bounds. And then we can use force weighting to say if the further that is, the closer we are to the boundary, then the greater this steering force should be. So as we get closer and closer to the edge, we want to seek away from this edge, or flee away from this edge in this case. All right. So let's take a look at what this would look like in code. So in my vehicle, I'm going to collapse this function here. And I'm going to make a function called protected. It's going to be protected. It's going to be a vector3. It's going to return a vector3. And it's going to be called stay in bounds. Now, in my game manager, I have a reference to the bounds. And what that is here is I have the ground here, which is a mesh render. It's a plane. And that mesh render has a bounds component. And in my game manager, I have just a way to access that ground's mesh render bounds function. So that's something that you'll need to have access to. You'll need to have access to the ground, or you'll need to have something that defines where your max position is and your min position is as well. So for the stay in bounds function, I am just going to say if my position dot x is greater than my actually I'm just going to say here bounds boundaries equals my game manager dot world bounds. So I'm just going to have a quick reference to that. So if my position dot x is greater than boundaries dot max dot x, or my position dot x is less than boundaries dot min dot x, or my, I'll put the or up here, or my position dot z is greater than my boundaries dot max dot z, or my position dot z is less than my boundaries dot min dot z. All right, so if I'm out of bounds in the x, then all I'm gonna do is, well, I'm going to return a seeking force towards the boundaries dot center point. So I'm just going to seek towards the center. And if I'm not out of bounds, then I'm going to return vector3 dot 0, because I don't want to seek towards anything if I'm out of bounds. So then in my zombie, I'll add that. So I'll say that my ultimate force is plus equal to my stay in bounds force, and then same in human. All right, and then in my vehicle class, I need to go back into my update, and I have this bounce function, so I'm just going to get rid of my bounce function. So I want to do it all with my vector movement. All of it should be done with my forces. So now, as my vehicles start to go out of bounds, you can see that they try to return back to the center. But since I'm not using any sort of force weighting, they are, you can see this zombie is having a really tough time. It's right on the edge, and it's trying to get to this human, but it's also trying to get to the center. And the human is probably directly opposite of the center, so the human's trying to move away from the zombie, and the zombie is trying to move towards the human. So the human doesn't know what to do because he's trying to go towards the center and away, and the zombie doesn't know what to do because she's kind of like in the same position. So we need to use force weighting to fix that. And we can do that pretty simply. We could say that we could figure out the distance between our position and the boundaries, and we could, the further out we get, the stronger we seek towards it. Rather than using the boundaries exactly, we could have sort of like a buffer zone where we want to make sure that they're staying in bounds. So like the real world bounds here, if I go back into my Paint app and just show what I mean here. Let's see, what do I want? I want a rectangle. So let's say that this is our world. We could create a buffer that sort of says, well, we really care about not going outside these like outer edges. So as soon as you, as a human or a zombie, go outside this like inner boundary, that is when we want to start seeking inwards. Because right now in my game, as as they get closer, they're only ever seeking towards the center if they're already off the world, which isn't maybe exactly what we want. So you can see how they can kind of get pushed off the map, and we don't want that. So we need to make sure that we have some sort of weighting forces where the closer we get to the edges, the further we should seek inwards. So this is the algorithm that I think you should use. You should be checking to see if the future position is outside, and then have them either seek towards the middle or flee away from whatever edge point they're going to hit. But this is something that I want you to code for yourselves. I think it's a good exercise in learning how all of these forces work together. So I'll let you guys have handle that. And that's where I'm going to end it for today's demo. I know it went a little bit long, so thank you for sticking with me. The only work that you have for this week is to work on Project 3. So keep that in mind, that is what you should be focusing on. And as always, if you have any questions, feel free to ask it in Slack in the help channel or in a direct message. All right, well, I hope everyone has a great week, and I will see you soon.